Can you solve this simple question on nuclear decay? Now the question says that fluorine is found to undergo 10% decay in 366 minutes. What is its half-life? Now the half-life is simply the time taken for half of the initial amount of a radioactive element to decay. So how do you solve this question? Again, this is a formula you need to have off head. The formula is ln n naught over n equals kt, where n is the initial amount, n is the amount that is left at time t, and k, we call it decay constant. So from the question, what is going to be our n? Now, the question says that it undergoes 10% decay. Now, if we should express this out of 100, then that means that the initial amount was 100. And then it undergone 10% decay. That means that what is left is what? 90 out of the 100. So n is going to be 90. So all we have to do is to put this in the equation, and then the t is also given to us to be 366 minutes. So if we put this in the equation, we are going to have ln of initial amount, which is 100, over 90, which is the amount left at time t, and this should be equal to kt. So we have the k, and the t is what? 366. All right, so if we take the ln of 100 over 90, that is ln of 0.9, and this will be what? 366k. Okay, and this will give us a value of, let me punch that on the calculator. So ln of this will give us 0.105 equals 366 over k. Now this means that k would be equal to 0.105 divided by 366 minutes. So k will be equal to, k would be equal to 2.88 times 10 exponent minus 4. So now that we know k, it will be easier for us to provide what the question is demanding for, which is half-life. Now we know that k is also expressed as 0.693 over t half, where t half is equal to half life. Okay, so we have k to be 0.693 over half-life. This means that if we make t half the subject, will have 0.693 divided by k, and so t half is equal to 0.693 divided by 2.88 times 10 exponent minus 4, and this would be equal to 2406.25. So the half-life of fluorine is 2406.25 minutes. I hope this video helps you to prepare for your exam. Thank you.